We're starting Unit 2 today, and that starts with parallel lines and, well, parallel planes and skew lines as well, but mainly parallel lines, and then we'll start talking about how angles will go with those here in a little bit. But to fill in the blanks at the top, hopefully you've all seen parallel lines before, but two parallel lines are two lines that do not what? They don't cross, they do not intersect. That's exactly right. So they keep going in the same direction forever, right? And they would never cross even if you was to keep extending them out. This next part will probably be new. It says arrows are used to indicate that the lines are parallel. And so what that means, if I look at this little figure here, does everybody see those arrows that are on each of those lines? Anytime you see that, that's telling you that those two lines are parallel. And how I would say that is I have line AB. Remember, that would be a line over top of two arrows on each side, or an arrow on each side. This with two straight up and down lines means parallel. That is your symbol for parallel. And so line AB is parallel to the line CD. You'll see this a lot. You just always have to remember that that means parallel. If we move down to the second square, this one is talking about parallel planes, and that's basically the same thing. Parallel means they do not intersect. So this is planes that do not intersect. Remember, a plane is a flat surface. So if you was looking at a room, the floor and the ceiling and the floor would be parallel, right? They would never intersect, they don't touch each other. Or the left wall and the right wall would be parallel to each other. But if I have one of the side walls and the floor, they touch or they would cross. So those are not parallel, right? Again, the symbol is the same. Anytime I see this, that's always going to mean parallel. But then I could just say plane J is parallel to plane K. Now, skew lines is probably new for you. And the only time you'll have skew lines in a picture or anything is when you have a three-dimensional picture there to look at. How I talk about this, first of all, just to say the mathematical language, it would be non-coplanar lines that do not intersect. And what that means is these lines are they're not going to intersect, but just because they do not intersect does not necessarily make them parallel. And I'll show you some examples of that here in just a second. Because basically, just make a little note that they do not go direction. And that'll make more sense after we do these three examples here. So if I'm looking at this three-dimensional figure, I'm treating each of the edges like a side or like a line. So let's say I start with the side, the segment PS. So that would be this segment down here, right? All of the edges that go the same direction of that would be parallel. So everything that's from front to back would be parallel. Now skew means it's not going the same direction but will not touch. So what that means is I go to a different side. So PS is on this side over this left side over here, right? Well, if I look at VR, is that going the same direction as PS? It's not. But if I'm looking at it like it's the classroom, PS would be at the bottom edge of that side over there, and VR would be going up in the back corner. So they're still never going to cross, right? And so that's what skew means. They never cross, but they are not going the same direction. So you could also, QU would also be skew to PS, right? Now, TP and WS would not because they cross or they touch. So just for another example, let's say I have the segment TW. I need something that's not going the same direction as TW and doesn't touch it. So I come over here. I have UQ or QU. Also, VR would work for that one too, right? It goes a different direction and never touches it. And if I have PT, that's going up to down. I need something that's never going to touch that. So RQ or VU, right? Does that make sense to everybody? It's not going the same direction, but it cannot touch. So I'm going to do example 1, then we're going to take a short little break while you do example 2. Actually, I'll do example 2, then y'all go back and do example 1. So example 2 says name all these segments parallel to the segment JK. I go over here and find JK. Usually there's a multiple segments that would be parallel if I have just a regular cube or a box. But this is like a three-dimensional pentagon. So it kind of looks like a house. So what's the only other segment on here that's going the exact same direction as JK? OP, all the way across from the other side, right? So that would be my parallel segment for JK. Now it says name all the parallel segments to NS. I have a lot here. NS is going from front to back. That means every other segment that's going front to back is going to be parallel to NS. So I have NS, then I would have MR, right? Then I would have LQ. Then I'd have KP. P. And then my last one would be J O.
What's the symbol for like a plane? You write plane, you write.
There's not really a symbol. Most time you just have to write out plane, like the word plane. C says name a plane parallel to plane JKL. First of all, I need to figure out which one that is. And remember, it will just use 3 letters, but it's talking about the entire side. So if I look at JKL, they're all on this front pentagon side, right? Well, the front would be parallel to the back, right? So my parallel side, or my parallel plane is going to be on the back. So I'll say plane, and there's different ways you can name this. I can use any 3 of these letters back here. I always, just to keep it the same, since it said JKL, I'm going to use the same letters on the back, and I'm going to say OPQ. You don't have to do that. Just any 3 of those 5 between Q, P, O, S, and R. And now D says name 4 segments that are skew to the segment RQ. Now remember, that means they never cross RQ, but they are not going the same direction. There's actually 4. So RQ's up on this back, slanted to the right side. So somebody give me one that should be skewed. It can't be the same direction, but will never cross. LK or KL. It's going up and to the right, but that's never going to cross the RQ because it's on the front, right? Alright, and a good thing to look at, anything that's going to be skewed to RQ will have to come from this front, right? Because anything else, well, maybe not necessarily for this one, but most of the time it'll have to come from the front because anything else would maybe cross RQ, right? So KL, it cannot be LM. LM would be parallel, right? MN would work. It's not going the same direction. And then JM.
Is that MN?
Yeah. And then JN or NJ. And then there's one more on the front side, and that would be JK. And that is all of them. And I was right. Well, that's not actually all of them. Because now, there's actually 2 more. But it just says name 4. But we'll talk about those 2 more. I could have PK, right? It would be going underneath the RQ. It would never cross. I could also have JO. And I could also even have OS.
So you're just looking for the ones that are not parallel?
But they cannot touch it. Yeah. Not parallel, but they cannot touch it. That's what skew means.
What about
NS would work, yeah. Alright, so right now, take the next 5 minutes or so and go back up and do example 1. It should be it's more simple because it's just a rectangular prism.